Good morning and welcome to another episode of SMECO Connects. My name is Sonja Cox and I'm your host, and I'm joined today by my co-host Tom Dennison.
Happy to be here, Sonja. Thank you very much. It's another good day for a podcast, and today we're joined by one of SMECO's engineers. So Alex, give us, introduce yourself, tell us where you're from and kind of how you came to SMECO.
Hi, my name is Alex Santiago. I'm from Springfield, Virginia, so not too far from here. I came here to SMECO through my college, Virginia Tech, where I hold a Bachelor's of Science and a Master's of Science in Electrical and Computer Engineering.
Awesome.
I'm very happy to be here. Thanks for having me.
Thanks for being here.
So how long have you been here?
So I've been here for 2 years. I started as soon as I graduated college. It was in June of 2023. So I just recently passed my 2-year mark.
Nice. And I know one of the initiatives Sonja has really talked about and kind of spearheaded here at SMECO was the need to attract new engineers to come to SMECO. Give us a little bit of background about how you heard about SMECO and kind of what led you to coming here.
Yeah, I mean, I think it's very much general in the power industry. There's not a lot of, well-qualified engineers. I think we're very lucky to be in an area, the DC metropolitan area, where it just has a lot of qualified candidates and great schools. I found out about SMECO through the career fair where I first met with, I believe it was John Breedenkamp, our transmission vice president, and I think it was Ben Fonts, which is also in technical services doing transmission work. This was in the fall of 22, so my junior year. And I remember them telling me, come back to me next year. And so I did, and here I am now.
Awesome.
So,
And you just got a promotion.
I sure did. It's the nice thing about working in engineering. It's very stratified. We have certain years of experience where you qualify for promotions, and it's nice to be able to progress in a way that is consistent. And there's plenty of stuff you learn within the last 2 years. I would say I'm completely different than when I first started here.
Yeah, book work is one thing, but on the job is, you get to apply the things you learned in school, but you see it in a whole different way. For
sure. And I mean, there's certain things that, they teach you an electrical engineering education, but there's a lot of stuff unique to power, right? Three-phase power isn't something that's used a lot in like your smaller electronics. And it's something that you might learn in school, but you also might learn a lot on the job as well.
Great. And the next professional thing that you're doing for yourself?
Yeah, that'd be the professional engineering exam. Usually it's a bit of a process, but you start with the fundamentals of engineering exam, where you go over, it's more or less what you learn in school as an electrical and computer engineer. And then after that, you can specialize into specific fields, and there is a professional engineer in power.
Oh, awesome.
So I'll be trying to sit for that sometime this year.
Good. That's awesome.
Yeah, congratulations. That's wonderful. You were at Virginia Tech, and you went to the career fair. Talk to us about how the recruiting went. I assume you went up to SMECO's table, you had a conversation. Is that kind of how things transpired at the beginning?
It's very like open form. I mean, it talks more about what kinds of work you can do at SMECO, because, we say I'm a distribution engineer or a transmission engineer, but there's a lot of stuff that happens within those very broad general categories. They talk about, you could be more of a designer, more of a protection engineer, even communications. That's a whole other side of things, and we have a whole team for that as well.
So why don't we get into the I guess the topic of today, the reason you're here. So let's start with you. Tell us what you do as far as your job, and then we want to talk about how the power actually gets from the generator or the generating station to the house. So what are your duties as far as that goes?
Yeah, so I mostly have two main duties. My first one is in distribution protection, which is designing the distribution circuit to minimize outages to the best of my ability. And then my second one is in commercial design, which is mostly in figuring out the electric layout to feed large customers. Think of like a Costco, a Walmart, to even just smaller commercials like a local butcher shop.
Oh, okay. Well, let's talk about that then. How the power gets from the generating station down to the customer.
Yeah, of course. It's a bit of a process starting from the generation plant and ending at your home, but hope to be able to teach you a little bit about, how and why we do the things we do to get it from plant to your house. It starts off at the generation. That can be pretty much any form of generation, whether it's traditional like gas, coal, nuclear, hydro, or more new things such as like solar, wind, more renewable sources of energy. But irrespective of what goes on behind there, what comes out is a nice three-phase power signal of about 22 to 35 kV, which is kilovolts, thousands of volts. Once it has that electrical power coming out, it gets stepped up via a transformer. The long and short of a transformer is you have power coming in and you have power coming out, and those two are the same, but your voltage and current, which make up that power, are different. When you step up that voltage, you lower the current, and vice versa. The reason we do that is that when you have high voltage and low current, you can transmit at long distances and you have less loss within that line. So that's exactly what they do at the generation station. They step it up really high and then they transmit at long distances. In the past, it used to be that all that generation was done really locally because you couldn't transmit it very high. So, imagine if you were in New York City and you had a coal plant right next to your house because it needed to be close to you. Obviously, that wasn't ideal. So with the invention of that transformer to step it up, we're now able to keep our generation a bit further away and, follow with like local environmental laws and everything like that. Once it's at the transmission line, it'll go to a few substations, which are transformers, and it'll slowly step down the voltage till we get to a distribution circuit. A distribution transformer is actually known as a substation, and we have plenty of them in our system. There's actually one down the road in Hughesville.
Yeah, I think we have over 50, I think is the number that I recall. That was a few years ago, but we've probably built some.
I think we've got a few more.
Yeah, definitely.
So once we get to the distribution line, SMECO runs at 12.47 kilovolts, thousands of volts. And we transmit it short distances because there's more current, more loss. And we go to a distribution transformer, which ultimately results in either 120, 240 for your house, 120 for your sockets, 240 for your dryer, or we provide three-phase power to bigger customers at 120, 208, or 277, 480 volts.
Okay. And what determines whether you need, what helps you determine, or the customer determine which one you need?
So it has a lot to do with the equipment they use. Certain things like cream separators for farms or for on the commercial side of things, perhaps like big laundry machines might need certain power needs that just aren't met by that 120, 240 volt single phase service.
Okay.
So it's more on the customer equipment side of things than us per se.
And you get that information from when you're working with the developer or the builder on the commercial project?
Yeah, so we actually have them fill out an electric service request form, and that form pretty much asks what voltage do you need and how much power do you need.
Okay.
So that SMECO can make a good decision on how to best feed you.
Okay.
Yeah, it's that's got to present a lot of variety for an everyday kind of job. I would think that no day is the same for you in terms of designing different configurations to serve different homes, businesses, et cetera. Is that correct?
You'd be surprised. There's actually, once you start getting into larger projects, there are a lot more, multi-day things where you keep consistent to one project. But
Okay.
very much, especially when you start looking at older things, when we built them out, they have weird configurations, or at least configurations that we don't use as much today. So you have to be very cognizant of what the system looks like as it is now when you design for the future.
Yeah,
Okay.
that makes sense. Talk to us a little bit about the reliability aspect of your job and the devices and things that you design and kind of have the drawings out there for the guys to put in the system, and how that all is intended to help keep the lights on for people.
Yeah, so when you start talking larger design, we actually go through a process where we make an official D-size drawing. D-size is just very much a big piece of paper, right? But we go through, we draw out the lines, make sure it's clearing any water, sewer, any other utilities that we have to keep away from. But the big thing is for all your subdivisions and all your major commercial sites, we try and introduce a loop, whether that's a 1-aught loop, which is low ampacity, lower current loop, or a 750 loop, which is just a bigger wire, bigger current loop. We try and make it so that at any given point in time, one piece of line can go out and you can create a loop back so that as few customers are out as possible.
That makes sense.
So that fault could be isolated, and then the power can be rerouted so that more people stay on versus, and then that smaller number of customers who are impacted can, we can send out a crew and get that fixed and hopefully not impact as many people as possible.
It's very much to minimize the number of customers out, especially since in underground work, the safe practice is to do it while it's dead. So you have to make sure it's grounded on both ends.
Okay.
Understood.
So one of the questions that I get a lot of times is, I'm on this side of the street and I don't have power and my neighbor across the street does. So can you, from my limited knowledge of engineering, I would say you're on two different feeders. So, one side of the street might be on one and the other's on a different one. Is that pretty much the case, or?
So I think it depends, and it's the worst answer. My engineering professor used to always say it depends. It made me so mad. But it truly does, right? Because it could be that, there's a three-phase line going across one side of 235 and another on the other side of 235. And it very well just might be two separate feeds going in, and you just happen to be on the wrong side of it.
Okay.
But it could also very much be, maybe it's a secondary fault past the transformer, and everyone else in your neighborhood might have lights, but it just so happens to be that the secondary went out. These things do happen. It happens with age. We try and be very proactive about replacing things, but it's obviously, it can't be perfect.
Yeah, we're I believe we're still using it, but we had this, using data to look at the transformers, the distribution transformers, to see if they're overloaded. Are we still using that?
Yeah, so we actually have pretty much a report that runs, and it tells us, when we look at transformers, how loaded it is throughout the year. For engineering design specs, we try and keep it between 60 to 80% loaded. It minimizes the amount of losses. You can't get away from losses, but
Sure.
it gives you a little bit of slack in case it gets really cold or really hot, but it also keeps the losses low. And then we try and proactively replace whenever we find one that's overloaded.
Okay.
And that's something that is of interest to SMECO, because as you overload, you start to lose loss of life in that transformer.
So what if it was the opposite? Like maybe there's a 10% or 20%?
Yeah, and in cases like that, it actually is in the interest of SMECO to downsize it so that it matches the customer load.
Okay, and then you could downsize that one and then perhaps use that one someplace else.
Yeah, great example. Up in Calvert, there's one for, I think it's Northern Middle School, that was sized to be a 2500 kVA or 2.5 MVA transformer, and it uses somewhere in the range of like 500, 600 kVA. So for something like that, where we might need a large transformer with the lead times being close to 1 to 2 years,
Right.
it behooves us to at least have it, put a little star there and say, if we need this,
We have it.
it's good to replace.
Okay.
Solving problems. That's what engineers do, right? So, Alex, what do you see happening in the next, say, 5 to 10 years from a electrical distribution standpoint that could be something for people to look out for, or something that you may be particularly excited about or challenged with, or anything as it pertains to the future of your job?
I think the biggest thing to think about is, if it's one word, it's electrification, right? I mean, the state of Maryland's pushed very hard to, get rid of gas and have all these initiatives to be more electric reliant. And that causes a lot of problems in the loading side of things, and we have to be very cognizant of planning for the future, right? That might mean adding substations or increasing transmission lines, but finding a way to have more supply available to the best of our ability. Obviously, the grid is a very interconnected system. The entire eastern seaboard's interconnected, so it's a bit of a group effort, but at least on our end, to try and be proactive about it.
Yeah, I think that is something that's consistently we've heard, Sonja, whether it's been on these podcasts or just from elected officials and the Maryland Public Service Commission, the effort to electrify. And I think when you talk about electric vehicles and retrofitting garages, for instance, so that they all have the necessary infrastructure to allow for a customer to plug in their EV, also to accommodate distributed energy, your solar and on site or on your rooftop, those types of things. I mean, that's just something we've been leading on really over the last, at least in my 20 years here, almost 20 years, we've really kind of embraced that and tried to push it forward, but the efforts are going to continue.
Right.
There's no doubt about
Right.
that. Alex, the other thing that I wanted to ask about was the kind of the growth of Southern Maryland. Do you see the growth in the commercial side and the residential side, and kind of how we extend our system to those customers, and kind of does that present any challenges for you?
So it's more on the electrification, on having to plan for it in terms
Right.
of challenges. But in terms of growth, I mean, you could go drive down the street, right? Mattawoman, La Plata, Waldorf, all these areas are finding a lot of growth in the residential sector. And what you usually find in the growth of cities is that once the residential starts to build out, then the commercial comes, right?
Okay.
So we're very much still in the infancy of having this kind of boom in residential, especially up north.
In the
And-
Brandywine area, northern
Yeah, it's
Waldorf, yes,
Yeah.
it's very intense. I think is
It's-
the way to describe it.
I mean, I've only been here 2 years, and it's almost impressive what I've seen go up.
Well, and then just what they're doing in Charlotte Hall, it seems like it happened overnight.
Yeah.
So there's a lot of growth down there on the commercial side. Mm-hmm. So have you been involved in those projects?
Yeah, so I actually I've been feeding the power to that new Weiss, the new
Oh, yeah.
Chick-fil-A, at all a bunch of those services were actually my designs.
Oh, cool.
Wonderful. It's got to be kind of interesting to know that, right?
You know, there's a bit of a pride in going down, you know, especially with a Chick-fil-A, because it's like I can tell my coworkers, hey, that's me. No, like I said, it's all kind of a group effort, because there's a lot of stuff that goes beyond the meter as well. There's a lot of stuff, whether it's the construction or the actual wiring that electricians have to do. So it's a lot of making sure that we're on time so that we can meet what they need.
And do you ever go out in the field before you design a job, or?
So yes, we tend to do that whenever it's, you know, if you have any questions, any lingering thoughts, it's good to always go out there and, you know, see what's actually out there, because our system that shows our lines and our transformers, they're great, but they're not always 100%.
Okay.
So it's always good. Or even if, a great example, I was designing some apartments down in Lexington Park, and I wanted to use a pole to run new 750 wire. And I went, well, hey, I should probably look at this pole, make sure it could hold it, or if I need to replace it, right? It's stuff like that where you really want to be granular and be specific in how you want to do things.
So when you go out there, or if you're like on a job site and our guys are there, do they ask you questions, or do you guys talk about the service that's being installed, or?
I mean, I've chatted with the guys before, and I have a fun story from when I first started, where I was driving with another engineer, and we ran into a bunch of guys actually serving an outage, and we were able to pull up the maps for them to find out where that normal open point was to try and backfeed the customers. So it's something that you do on occasion. I said I'd try not to interrupt them while they're doing their thing.
Yeah, no doubt.
They're definitely a lot more qualified on that side than I am.
They like to talk about what they're doing, though. They enjoy that, or at least they enjoy telling me.
Exactly.
Or I think they do.
Yeah, I got to tell you, Sonja, I've had an interaction with Alex in terms of a complicated matter down in Great Mills, where we had, you know, one building and they needed to have separate meters, and there was, you know, just a lot of effort and a lot of balls in the air. We had developers, we had electricians, we had inspectors, we had elected officials, we had the whole kit and caboodle. And I got to tell you that it's really refreshing to call somebody like Alex here internally and know that they have everything documented, all of the the drawings. This is when we gave the drawings to the developer. This is when the electrician is scheduled. I mean, I think that's a level of customer service. I think that is really important, and I know certainly helps me in my job, and I know it helps you as well. So, Alex, just from your standpoint on the engineering side, how important is it on the customer service aspect of your job? And I assume that takes up a lot of your time.
It does take up a bit of time. I would say a lot of our stuff is trying to get stuff out on time, correct and accurate. Mostly because, I mean, we get a lot of jobs. That's true irrespective of just me. It's also the distribution designers. They have a lot of work to do as well. So we really try and be on time and as best as we can. Obviously things come, things compete. But in terms of documenting things, we try and be very meticulous on how we do things, try and make sure that things flow evenly.
Yeah, I know in my experience, a lot of times the folks, whether they're building a new house or developers building Costco, I mean, they just kind of need to know like a timeline generally. If you can give them a timeline and a kind of just sort of set their expectations, that's a huge thing. And the worst thing is when phone calls don't get returned or emails that linger on for weeks and weeks and weeks. It's the uncertainty that really kind of usually creates problems. So credit to you, and I know you've only been here for a couple of years, but it's got to be, I think, part of your job to know how important that is to serve our membership here at SMECO.
Well, they are customer members for a reason, right?
Yes, that's true.
They're very important to us.
So how about, we're hearing a lot about data centers. Have you been involved in any of that talk so far?
That tends to go up the chain because it's a little bit more of a high-stakes job.
Right.
I know in general, the state of Maryland has been very, they've been pushing the lead on wanting more data centers and wanting to have that sort of capacity available for data centers. Very similar akin to what goes on in Northern Virginia, close to my home. Where there's a lot of data centers and they are everywhere.
They are, yes.
But they tend to bring their own pros, their own cons. It's a lot of capacity is the big issue right now, and a lot of it for Maryland is actually generation, because Maryland is a net importer of energy, so they take in more energy than they produce in state. So that can cause some strain on the transmission lines and can really make PJM's job hard, which is our independent system operator for our entire region.
Right. And it can probably, I mean, if we're trying to bring more power into the state through the transmission lines, then that's going to increase our cost for transmission services with PEPCO. So, I mean, I think that's one reason why it is a big deal that we're a net importer. But
I think it really just boils down, at least in my opinion, to that energy concern, right? Having enough capacity, because when you have a strained system, you just pay more for energy. So it's really about having a robust system to create new energy sources, regardless of what they may be, and try and get that constraint to be less of a problem.
Well, I think that goes back to what you were saying when we first started talking about, electrification. So we have electrification on one hand, and then you have all these data centers that want to be built on the other hand, and you put those two together, and it's just not a very positive outlook as far as generation goes.
I think the other thing you got to think about is up until very, very recently, we haven't had a way to store this energy. Right? When you produce power, it is used the instant it is produced. So it's very much kind of like a seesaw. And when you're adding a lot of data centers, you're adding a lot of electrification without really adding that generation, you start to balance it the wrong way. You start to create issues because you're not balanced. And a few solutions for that could come from like battery technologies. There's all sorts of discussions and research being done on can we store this energy in ways that are efficient and useful.
So what would you say, I guess batteries right now, there's no long duration storage answer at this point. And again, in my opinion, we have to get to there. We have to get to long duration storage along with the renewables in order to move away from fossil fuels. So I think sometimes we being the powers that be in the federal government and the state governments, we tend to kind of put the cart before the horse sometimes. I don't know if you're probably too young to know that saying, but anyway.
I think it's well intentioned. It's very much battery technology is still very much in its infancy. I mean, we've relied on lithium ion for so long. I mean, even our cell phones have lithium ion batteries, and there are very innovative companies that are trying to do different things, right? Try like flow batteries or different chemistries. It just needs time. That's really all it is. It's time and dedicated research.
So, what are your thoughts on this small modular reactor? SMRs, nuclear power.
So this would be completely my opinion, but I think nuclear, when you look at the reliability indices of different generating plants, nuclear has by far been the most reliable power. It's on upwards of 94 to 96% of the time. It's very rarely off, and there's obviously concerns about, well, what happens if it fails, right? We try and build as many safeguards as we can into it. The small modular reactor obviously is not brand new, but it's a newer development, and I think it's of unique interest, especially to the United States, where we might not have coal forever, we might not have oil forever. These things are non-renewable sources of energy.
Yeah, I read that TVA had done the first application for SMRs, so I'm going to follow that closely. When I started working, I started out in a nuclear power plant, so yes, run 24/7, and if you have 2 units like Calvert Cliffs does, you can do outages every other year on 1 unit, so you still have 1 unit running. And I'm a true believer in nuclear power. I think it's safe. I think it's clean, and I think it still needs to be part of the solution in the future.
I think at the end of the day, right, we can try and say pros and cons for different fuel types, but it's going to have to be a mix of them all, because there is no one perfect source of power, right? Solar is great. It obviously has its downsides. When the night's out, it's not going to produce anything. Wind is the same way. If it's not windy, it's not going to produce anything. But if you have a mix of all of these things and some form of storage, I think that's where you start to see the magic happen.
Right. No, I agree with that.
We like the magic. Yeah, we like the magic, and I know certainly the state of Maryland is in the process of trying to incentivize small modular nuclear reactors through adding them to the renewable portfolio standard that we all the utilities in Maryland are part of. But I don't know about you, Sonja, but I feel a lot smarter today. I mean, hanging around with Alex is a great education for me, and one example I think of the brain power we have here at SMECO. It's something I think we can all be proud of.
Yeah, I agree. Thank you for coming on today.
Well, hey, I really appreciate it.
Thanks, guys. Thank you.
Thank you.
Thank you, guys.